and carbon dioxide. Okay. So 4 stages. So this is a very important hydrolysis, acidogenesis, acetogenesis, and methanogenesis. So let us look at different applications. So இதுல வந்து பாத்தீங்கன்னா we can convert it into divide it into two sectors: low rate anaerobic reactors and high rate anaerobic reactors. ஸோ லோ ரேட்ல பார்த்தீங்கன்னா இட் வில் பி இன் நம்மளுடைய கன்வென்ஷனல் செப்டி டேங்க், இம்ஆப் டேங்க். ஸோ மேஜர் எக்ஸாம்பிள் வந்து பார்த்தீங்கன்னா செப்டிக் டேங்க். ஸோ இது வந்து பார்த்தீங்கன்னா கன்வென்ஷனலி எவ்ரி ஒன் நோஸ் தி. ஸோ டுடே ஐ வில் பி கோயிங் டு டிஸ்கஸ் அபவுட் த ஹை ரேட் anaerobic reactors. So why we are calling is a high rate? So the loading rate of the COD will be vary from 5 to 20 kg of COD per meter cube day. பட் இப்போ வந்து லோ ரேட் anaerobic reactorல பார்த்தீங்கன்னா it will be 1 to 2 kg per COD per meter cube. So the example for high rate anaerobic reactors வந்து பார்த்தீங்கன்னா anaerobic contact process, anaerobic filter, upflow anaerobic sludge blanket, and fluidized bed reactor, hybrid reactor. So hybrid reactor na it will be combined of it may be combined of any two anaerobic treatment process. So here I will be going to discuss about UASP and anaerobic filter. It's some simple example I am going to give. Then anaerobic sequence batch reactor. So sequence batch reactor வந்து பாத்தீங்கன்னா it will have a 4 steps as நம்ம ஆல்ரெடி ஏரோபிக் டிஸ்கஷன் ஏரோபிக் ட்ரீட்மெண்ட் பிளான்ட்டுக்கும் அதே தான் போறோம். பட் anaerobic ட்ரீட்மெண்ட் பிளான்ட்ல வந்து பாத்தீங்கன்னா இந்த ஆப்ஷன்ஸ் ஆஃப் ஆக்சிஜன் it will be. So anaerobic, so I will be going to discuss anaerobic filter, upflow anaerobic sludge blanket, and fluidized bed reactor and hybrid reactor. So these 4 reactors are conventionally followed for the industrial as well as the domestic wastewater treatment system. So இதுல வந்து பாத்தீங்கன்னா we can remove up to COD 80 to 90%. So generally aerobic treatment process it will be designed based on the biological oxygen demand. High anaerobic treatment process will be designed based on the chemical oxygen demand. So this we need to understand while designing the any treatment system. So இது வந்து பாத்தீங்கன்னா anaerobica aerobica அப்படின்றது வந்து கண்டிப்பா நம்ம வந்து தெரிஞ்சுக்க வேண்டியது இருக்கு. So in between any doubt na you can call and you can unmute and ask the question because I'm not able to see the messages. So please call and ask, unmute yourself and ask the questions. Sometimes it will be so. So இதுல வந்து first we will see the upflow anaerobic filter. So filter means it's a simple filtration. We are providing a media. So வந்து MBBR இல்ல பாத்தீங்கன்னா we have seen the MBBR media. In this case we are giving the anaerobic filter media. So I will discuss what is the difference between MBBR media and the anaerobic filter media. So same process. So it's a laboratory scale schematic diagram. So எப்பயுமே வந்து பாத்தீங்கன்னா aerobic treatment everyone வந்து பாத்தீங்கன்னா top to bottom side. So top to bottom தான் flow ஆகும். அதாவது water will come from the top அப்படியே வந்து பாத்தீங்கன்னா bottom to bottomல flow ஆகுற மாதிரி தான் டிசைன் பண்ணியிருப்போம் aerobic system. Or it will be இங்கேயே வந்து பாத்தீங்கன்னா effluent வந்து போற மாதிரி, அதாவது influent and effluent will be in the same height. But anaerobic treatment processல either top to bottom or bottom to top. அதாவது வாட்டர் வந்து பாத்தீங்கன்னா எய்தர் டாப் டு பாட்டம் அப்ரோச்சா இருக்கும் ஆர் பாட்டம் டு டாப் அப்ரோச்சா இருக்கும். ஜென்ரலி anaerobic treatment filterல வந்து பாத்தீங்கன்னா we need to maintain high retention time, high hydraulic retention time. So அதனால we will be going for bottom to top approach only. So to give more hydraulic retention time and high sludge retention time, we are going bottom to top approach. So it's a kind of thing. So temperature is a one thing. Temperature அதிகமா இருந்துச்சுன்னா reaction rate will be very high. Temperature கம்மியா இருக்கும்போது it will affect the reaction rate. So media, we will be filling the media. So water will go to the bottom of the tank and it will come top of the tank. So effluent and the treated effluent will come from this point and we will get the biogas. So this biogas can be used for the domestic purposes. So in this case என்ன மாதிரி filter யூஸ் பண்ணுவோம்னா these are the some kind of filter anaerobic filter media. So originally when it was developed anaerobic filter they used the rock. ஸோ ராக் தான் வந்து பார்த்தீங்கன்னா, கிராவல், ராக் அந்த மாரி வந்து யூஸ் பண்ண ஆரம்பிச்சாங்க. பட் லேட்டர் என்ன ஆச்சுன்னா, அந்த ராக்கோடைய எல்லாமே வந்து பார்த்தீங்கன்னா, கிளாக் ஆகி இந்த வாட்டர் வந்து பாட்டம் டு டாப் அப்ரோச் தான். ஸோ வாட்டர் வந்து கிளாக் ஆகி ஆல் த pores in the rocks and gravels getting clogged. So the water is not coming to the top of the reactor system. So then after that only people have identified these are the some anaerobic filter media. So this is similar. This looks similar to the MBBR media, but only thing is MBBR media will be manufactured using virgin plastic, but இதுல anaerobic media is mainly used for the recycled plastic. Okay, so MBBR மீடியால வந்து பாத்தீங்கன்னா we need for the treatment. இங்க வந்து only we are providing the media to increase the hydraulic retention time and sludge retention time. So on the now many synthetic medias are made up. So void volume 85 to 90% இருக்கணும். Then specific surface area of the this anaerobic media is 100 meter square to 100 meter square bar meter cube. But in case of MBBR media, it will be 400 to 700. So the surface area of specific surface area of MBBR media will be very, very high compared to the anaerobic filter media. So this is the one of the difference. Then upflow sludge blanket. So up to now, anaerobic filter on the pathina, we are not at all using for the real time operation, because in the filter media will get clogged, and on the pathina maintenance பண்றது very difficult, because once we install means we have to lift entire media for the maintenance. So clog ஆகி இருந்துச்சுன்னா இந்த மீடியா எல்லாத்தையும் வெளியில எடுக்கிறது வந்து it's a laborious work, and it is time consuming. So then really people have developed anaerobic sludge blanket. So this was developed in 1970. So this is mainly used for the industrial effluent as well as the domestic effluent, where the COD and BOD to COD ratio is little higher. So BOD by COD is called as a biodegradability index. So whenever the biodegradability index if more than 0.3 or 0.3 to 0.5, we are going for the anaerobic sludge blanket reactor, UASB reactor. For industrial வந்து பாத்தீங்கன்னா it will be on a COD will be very high. So directly we will be going for the UASB reactor. If industry is interested to do any biological treatment, it will be mainly used for the industrial purpose. So the granule size, once the biomass is grown means, okay, I will show the video, some animation. So then it is the same bottom to top approach. So influent sewage or effluent influent will be coming there. So here biomass media will be there. So these are the granules are considered as a biomass media. The yellow color is will be the biogas. So in the granule media உடைய ஒரு பிக்சர் தான் இது. பட் whenever aerobic treatmentல பாத்தீங்கன்னா it will be more on separated particles. Like வந்து பாத்தீங்கன்னா it will be like a sand மாதிரி வந்து ஒரு particles each separate இருக்கும். But in case of UASB reactorல வந்து பாத்தீங்கன்னா biomass will be growing as a blank like granules. It will form the granules, so it will grow like a granulated structure. So easily it will be settled very quickly. So once on the pathina, if we do any maintenance activity means all the granules will be settled very quickly. Very quickly means it will be taking very less than 10 minutes. So 10 minutes la vandu pathina all the anaerobic granules sludge will be settled down. So effluent will be going into this, and biogas will be collected in the hood arrangement. Effluent and will be collected from the top of the hood. So இப்போ இந்த biogas வந்து will be collected and can be used for the utilities. Mainly in the industry they are using for the cooking purposes. So whatever gas they are generating, cooking purposes, sometimes boiler heat பண்றதுக்கு யூஸ் பண்றாங்க. So boiler heating purpose. So wherever heating is required, this energy can be used. Then fluidized bed reactor. So this is also same reactor. Here it's a packed media. Packed media will be will be there, and we will be providing influent, and it will enhance. So similar to UASB, but right now we are not using any FBR reactor for the industrial operation. Then hybrid system. So hybrid system வந்து பாத்தீங்கன்னா sometimes a little more advantage. um, so here I am discussing UASB plus anaerobic filter. So we can see that influent is coming, and sludge bed வந்துன்றது anaerobicல generate ஆகிற sludge, and we are providing a packed media. So and I have shown this. So this media will be packed as a one layer. So this media will packed as a one layer. So here biological anaerobic biological treatment will be happening. Here filtration is also will be happening. Why we are providing is, sometimes if the suspended biomass or some biomass are floating very high, means it will be entering into the gas system, as well as it may escape to the effluent. That means it will increase the suspended solid concentration. So to avoid that suspended solids concentration, we are providing this anaerobic filter. So this will filter the any suspended solids is coming out from the sludge bed. So water will come there. So also it will increase the solids retention time and hydraulic retention time. So this is the one major advantage. So இப்போ anaerobic filter க்கு அப்புறம் வந்து பாத்தீங்கன்னா the water effluent we are getting, it will be on very good quality, and this can be used for the gardening purpose. So generally effluent treated effluent treated sewage water will be used for different purposes in industry. One is for gardening, one is for road dust suppression purpose. இண்டஸ்ட்ரியில வந்து பாத்தீங்கன்னா வெஹிக்கிள் மூவ்மெண்ட்னால ரோடு வந்து பாத்தீங்கன்னா டஸ்ட் சப்ரஷன் பர்பஸ்க்கு வந்து they will be using very high. Then cooling tower will take very high huge amount of water. So fresh water வந்து யூஸ் பண்றதுக்கு பதிலா they will be using this treated water. Then boiler also they are using, and toilet flushing. So wherever the double plumbing system is there, they will be using for the toilet flushing purposes. So these are the different example for the anaerobic treatment process. So then now any doubt in this? So what is the major difference is? So major difference is aerobic. So we are using only UASB reactor right now for the industrial operation. So we are not using any other anaerobic treatment system. Only UASB reactor for industrial effluent treatment system. For sludge, we are using anaerobic digester. So it will be following all this treatment. So anaerobic digester. So only one digester will be there, and it will be all the 4 different treatment process will be happening, and the digestive sludge will be used for the used as a manure for the gardening purposes. So these are the example. So now I will show the next topic. It's a constructed wetland. So all the overall we have discussed on the man-made treatment process. So like வந்து பாத்தீங்கன்னா activated sludge process, MBBR process, MBR process, anaerobic digestion, all are there for the different developed by the man. So the constructed wetland is the nature bed. It's called as a biomimicry. So என்னன்னா ஸோ நேச்சரில் நடக்கிற வெட்லேண்ட் நேச்சுரலி அக்கரிங் வெட்லேண்ட் ப்ராசஸை we are mimicking into the man-made structure. So that is called as a constructed wetland. So I will show the simple 1 minute video how it has been generated. Is audio is available? Audio is coming. I will play the video one more again. If it's a very short video. Not audible. Okay. Sir, it's video is audible or not, sir? Video. Mm, okay, then we'll go to the presentation. Video, audio is not. Mm, This is a natural wetland. Rainwater that falls here filters through the soils, plants. Then it's slowly released into the downstream water. In the process, many pollutants are left behind, so the water that leaves here is cleaner when it enters. When we build neighborhoods and downtown areas, it changes the natural water cycle. With nothing to slow it down, rainwater rushes from the streets through storm drains to the creek, bringing all the pollutants with it. One solution to this is to design and build constructed wetlands. A constructed wetland helps us slow and filter stormwater in a way that's closer to the natural water cycle. The
Plants, soils, and pools in the wetland are designed to clean the water, and they also provide ecological benefits by creating habitat for wildlife and pollinators. To learn more, go to bermnc.gov/stormwater.
Okay, sir. I will send the video. It's a simple video only. We will discuss in the slides itself, sir. Okay, so the construction wetland are treatment systems are that are it's a natural process. It's a wetland vegetation. So the definition of wetland is the water will be stand always between 0.3 to 0.5 meter depth. எப்படின்னா பார்த்தீங்கன்னா வெட்லேண்ட்னா throughout the season of the year, throughout the year, so water will be stagnant with the depth of 0.3 to 0.5 meter அப்படின்னு வந்து பார்த்தீங்கன்னா ஒரு ஏரியாவில் வந்து வாட்டர் வந்து ஸ்டாக்னட் ஆயிடுச்சுன்னா we will be called as a wetland. ஸோ அதில் வந்து பார்த்தீங்கன்னா இட்ஸ் அ நேச்சுரல் வெட்லேண்ட் இருக்கு. அதாவது ஃப்ரெஷ் வாட்டர்ல இருந்துச்சுன்னா இட் வில் பி கால்ட் அஸ் அ wetland. Suppose if it is near to coastal area, it will be called as a marshland. So in Chennai we have the marshland. Pallikaranai is the one of the marshland. So அது மாதிரி பார்த்தீங்கன்னா it will sometime fresh water source ல இருந்துச்சுன்னா it will be called as a wetland. In terms of big structure, saline water பக்கத்துல இருந்துச்சுன்னா it will be called as a marshland. So major thing is it will be there will be the filter media and plants will be there. So இதுல வந்து பாத்தீங்கன்னா it's a combination of phytoremediation as well as the filtration. So now my voice is audible or not, sir? Okay. So wetland வந்து பாத்தீங்கன்னா it will be in two process. One is phytoremediation. So phytoremediation na the plants will remove the pollutants, general definition. Then second one is filtration. So both will be and it's in wetland வந்து பாத்தீங்கன்னா it will be naturally occurring system, but we are man-mading it will be called as a constructed wetland and associated microbial degradation as well as. So phytoremediation, filtration, microbial degradation. So all the three process will be happening in the constructed wetland. So I will be discussing each and every process and different types of constructed wetland commonly used for the treatment sewage treatment system and general one or example. So our laboratory studies la வந்து பாத்தீங்கன்னா how we can use this constructed wetland system for the sewage treatment. So with the one example, so okay, treatment mechanism வந்து பாத்தீங்கன்னா so we know that sand it will be filled by the sand, gravel and other filtering material. Then plants will be planted on the top of the soil, and it will be பாத்தீங்கன்னா it will be 0.3 to 0.8 meter. Sometimes it will go to 1 meter depth also. So it depends on the design aspect, and it depends on the flow. So water will be coming to here and will pass through all the plants and as well as the filtration system. So generally we will be providing outflow at the bottom of the sometimes there is a two approach. One is here also same approach. One is a top to bottom approach and bottom to top approach. This is mainly on horizontal flow, and bottom to means it will be the vertical flow. That differentiation will be the different types of wetland treatment will be I will discuss. So generally influent water is coming and it will settle on the near to the system, and due to the anaerobic condition this sediments will be digested. So வந்து பாத்தீங்கன்னா here we won't be providing any aeration to the system. So settle ஆகிற sediments வந்து பாத்தீங்கன்னா it will go to the anaerobic system. Then this sediment will be digested, and this digested sediment will be act as a manure for the plants on the top of the soil. Then we are providing sand and gravel. This will be the plant filtration system. Then second, plant learn one thing is root uptake. So plant nature whenever any nutrients are coming, so mainly on nitrogen and phosphorus. So if we know that sewage will have the definite quantity of nitrogen and phosphorus, and it will be very difficult in removing in an active sludge process. So active sludge process nitrogen and phosphorus remove பண்றது ரொம்ப கஷ்டம். So that's why we are providing additional nitrification, denitrification and anoxic process. அதெல்லாம் வந்து கம்பைன் பண்ணி தான் வந்து பாத்தீங்கன்னா we can achieve nitrification and denitrification. So but in this case constructed wetland பாத்தீங்கன்னா this nitrogen and phosphorus will act as a nutrients for the plant growth. So plant metabolism, so photosynthesis activities வந்து பாத்தீங்கன்னா it will be then okay then translocation from the root to root. So root ன்றது இங்க இருக்கு. So whatever the pollutants are coming from the influent wastewater, so it will be passed through in a horizontal manner, and the plant roots, so plant roots will uptake the pollutants and it will stored on the top of the shoot of the all the plants. Nutrients, if nutrients are coming means it will be used for the photosynthesis and it will be used as energy and it will improve the plant growth. In case of pollutants like BOD, COD, metals, heavy metals, then other inorganic compounds, it will be passed through the roots and it will be uptaken and it will be stored in the shoot, the tree, plant leaves, stems, all the spots it will be stored. So this is called as a phytoremediation. That means plants will remove the pollutants. So generally this pollutants will be stored in the roots and stem and leaves of the pollutant. So the concentration in the sewage will be less. So all the pollutants will be transferred to the root shoot of the, that means top portion of the plant. Then here also process will sedimentation, adsorption, precipitation, because we are providing sand, gravel and other sand, gravel and other filtration media. So I will give the one more filtration media. So one example, I will be discussing one example for the other sand, gravel, other. So இதுல வந்து பாத்தீங்கன்னா fine pebbles and medium gravel, fine gravel, sand, அதான் நம்ம யூஸ் பண்ணுவோம். We can use other than that some other materials also which are easily available in the market. So one example I will give in the later slides. So sedimentation, adsorption, precipitation. Then here will be the microbes will be there. So நம்மளுடைய anaerobic process இருக்கிற மாதிரியே here anaerobic process, because sediment are settling on the front portion of the constructed wetland. So இங்க வந்து பாத்தீங்கன்னா anaerobic process மூலமா, so anaerobic bacteria will act and it will be the complex organic matter will be converted into simpler organic matter. So then this simpler organic matter portion of organic matter will be removed by the phytoremediation action. Then remaining portion will be taken care of the microbial degradation. So நம்மளுடைய aerobic treatment processல இருக்கிற மாதிரியே both BOD, COD will be removed in the microbial degradation. So it will be acting as the complete treatment system. Okay, one is a sedimentation நடக்குது, anaerobic treatment நடக்குது, then phytoremediation நடக்குது, then microbial degradation, adsorption நடக்குது, precipitation நடக்குது. So sometimes in this heavy metals and other trace organic matters will be removed in the adsorption. Precipitation ன்றது வந்து பாத்தீங்கன்னா remaining chemical due to mixing all the particles will be settled down, so precipitated. So major the treatment process involved in the constructed wetland is the anaerobic treatment process, sedimentation, adsorption, precipitation, microbial degradation and phytoremediation. So this is the one, this actually இது வந்து naturally happening process. but we are man-mading into the artificially man-mading this system. Okay, then classification. So one வந்து பாத்தீங்கன்னா we can classify into the unplanted filters. So without plant வந்து பாத்தீங்கன்னா mainly வந்து பாத்தீங்கன்னா vertical and horizontal. So vertical means top to bottom தான். Horizontal means water will flow, sewage will flow in the horizontal direction. And another one is planted filters. One is with plants la வந்து பாத்தீங்கன்னா vertical flow, horizontal flow. So I will be discussing all these things. So இது வந்து பாத்தீங்கன்னா it will be called as a without plant it will be called as a subsurface filters, percolation pond, infiltration beds. But when it's come only planted வந்து பாத்தீங்கன்னா it will be called as a constructed wetland. So if the no plantation means it will be the it's like a filter media. If the plants are there means constructed wetland. So this is a one difference. So major difference வந்து பாத்தீங்கன்னா based on the operation, vertical flow constructed wetland, horizontal flow constructed wetland. And this is very, very important. Whenever we are designing a constructed wetland, there should not be the not too toxic component இருக்கணும். So வந்து பாத்தீங்கன்னா industrial effluent க்கு we won't suggest this constructed wetland operation, and we need to provide sufficient light because photosynthesis activity temperature not too low. So because sometimes வந்து பாத்தீங்கன்னா temperature ரொம்ப அதிகமா இருந்தா microbial degradation, plant growth and other process won't happening, and adequate quantity of nutrients. So this is will be the detention time. So we have to provide long hydraulic retention time. So long hydraulic retention time means we need high area, then organic loading rate and enough space. So we need enough space. So generally because of this disadvantage, so வந்து பாத்தீங்கன்னா it will be used as a tertiary treatment. ஒரு biological treatment process முடிஞ்சதுக்கு அப்புறம் hydrolysis sludge process, so MBR treatment process முடிஞ்சதுக்கு அப்புறம் we can provide as a tertiary treatment. So இது வந்து பாத்தீங்கன்னா வேற அப்ளை பண்ணிருக்காங்கன்னா பிரசிடென்ட் டெல்லியில வந்து பாத்தீங்கன்னா பிரசிடென்ட் உடைய அவருடைய staying place, accommodating place ல வந்து பாத்தீங்கன்னா this constructed wetland treatment process was implemented, and அது constructed and developed by the L&T. So L&T தான் வந்து பாத்தீங்கன்னா இந்த process around 2 mld sewage treatment. So அதாவது initially biological treatment வரும், then later biological treatment they will be using constructed wetland as a tertiary treatment. So வந்து பாத்தீங்கன்னா president உடைய ஹவுஸ்லயே வந்து பாத்தீங்கன்னா this treatment process are processed. So you can go in the internet and you can check that. So classification is a surface water flow, free water and subsurface. So that means surface la water வந்து flow ஆகி போயிடும், or water will flow from in the subsurface system. So based on the plant species, floating plants போடலாம். Suppose in case of floating plants, submerged plants, emergent plants. So these are some examples. So இது வந்து பாத்தீங்கன்னா no need to go in deep on that. So subsurface, surface, vertical flow தான். So compared to all these things, vertical flows வந்து பாத்தீங்கன்னா will come oxygen depletion problems and boost nitrification. So we'll see. So these are the types of plants suggested by the ministry. These are the plants can be used as a for the constructed wetland operation. So this is some of the aquatic species இருக்கு. Here aquatic species as well as the then scientific, it's a emergent species also there. So we can use any of the system. So this duckweed species, இது வந்து பாத்தீங்கன்னா you can see that in any lake and in the weed, the duckweed தான் வந்து பாத்தீங்கன்னா most of the time it will be on the top of the eutrophication process here. So how aquatic plant remediate na? So so as already discussed, it's uptake of nutrients and thing. Then also it will remove sulfur, iron, copper, selenium and other heavy metals. So other heavy metals also it will be removed by the aquatic plants. So now we will see one by one different types of constructed wetland. So this is a free water surface flow. So water so if you see that it's a wetland. So here வந்து பாத்தீங்கன்னா media we are providing and the slope is 1%, soil and sand or gravel, and watertight membrane. So bottom we are providing a watertight. So generally HTP membrane or cement வந்து பாத்தீங்கன்னா RCC platform or PCC platform will be given for the thing. So this is very simple operation. So wastewater will come and will pass through and will be settled. So பாத்தீங்கன்னா it's look like our aeration tank, water இங்க வருது, then again it is going to this system. But the problem is there's not much treatment will happen because water வந்து infiltrate ஆகி உள்ள போனதான் there will be a filtration இருக்கும், microbial degradation process இருக்கும். So இதுல வந்து பாத்தீங்கன்னா water உடைய depth it will be 50 centimeter only and the area required is 5 to 10 meters squared and population equivalent. So we will see this calculation how we can calculate this area. So this is a free water surface flow constructed wetland. Then this is a submerged beds. So இது வந்து பாத்தீங்கன்னா it is a horizontal subsurface flow. That means water நம்ம வந்து we are providing gravel and sand and sand system. So water effluent will come to here and it will pass through the pores of the media present here and it will pass horizontally and finally it will coming to the drain system. So here the complete constructed wetland treatment process is happening. Here sedimentation will have anaerobic treatment will be happening, and here all the physical process, sedimentation, absorption, and other process will be happening here. Also phytoremediation, microbial degradation will be happening, and finally in the bottom of the tank we will be collecting the effluent. So all the process will be used. So here the water flow inside the layer of sand will be 60 to 80 centimeter. So emergent plants like cattle and reeds are waste. So the land area requirement is 3 to 5 meters square. Here if you see 5 to 10 meters square, because we இதுல வந்து பாத்தீங்கன்னா water வந்து will be passing, it's like a flowing water. So we need to provide higher hydraulic retention time. So that's why here higher area is required. But in this case, we are providing hydraulic retention time very high in manner. So 3 to 5 meters squared per population equivalent, it's sufficient for the treatment process. So where we applied means whenever we are providing septic tank, this treatment system can be applied. Okay, so we cannot generally constructed wetland, it is not suggested to take direct wastewater treatment system. That means direct sewage வந்து நம்ம வந்து ட்ரீட்மெண்ட் பண்றதுக்கு யூஸ் பண்ணவே வேணாம். யூஸ் பண்ணன்றது சஜஷன் கிடையாது. எய்தர் ப்ரீ ட்ரீட்மெண்ட் பண்ணி பண்ணோம்னா we will be getting high quality effluent. Sometimes if we are providing direct effluent போட்டீங்கன்னா here sometimes it may be the clogging will be happening and it will be generating the foul smells வந்து பாத்தீங்கன்னா very high. But in case of septic tank, if you provide, so septic tank will be work in the anaerobic process, and constructed wetland will be the working on both physical, biological and treatment process. So also phytoremediation. So mainly to avoid clogging. So clogging of this filter media, if you provide septic tank kind of structure means we will get the high quality effluent and it won't affect the process. So sometimes if a clogging if clogging ஆயிடுச்சுன்னா we need to regenerate it, or sometimes if top of the soil வந்து suspended solids or settle ஆயிடுச்சுன்னா it will be taken by the plants. So that suspended soils or degradable matter will be taken as a manure and it will promote the plant growth. Then vertical filtration. So here water will come from the top to bottom. So inge pathina it's a flow of water is in the horizontal direction, but in case of here it will be in the vertical direction. So vertical direction la poi we will be providing perforated pipes. So the perforated pipes will so that means inlet perforated pipes, effluently perforated pipes. So water will be coming out from this and it will be traveling by the top vertical direction. Then finally here we will be providing a perforated collection system. then treated water will be collected through this. So here also, if you see this area of yeah, land required for vertical pipe is 2 to 3 meters squared per. So here it is 3 to 5 meters squared per population equivalent. Here 2 to 3 meters squared per population equivalent. It's a surface area. So this is an example. So water will be providing, so vertical type system example. So water will be passing in a vertical direction. So height will be, maybe we can provide as a 80 centimeter height. Slope is 1%. Then water will go passing through the system, and finally outlet will be collected from the system. So this can be used as for the groundwater recharge also, because it's a high quality effluent. So this can be used. So 3 types is vertical, horizontal, free surface water, free water surface flow, horizontal flow, then vertical flow types. All these are the different kind of vertical constructed wetland. Then hybrid system. So hybrid system na both horizontal as well as the vertical treatment process. So if இங்க வந்து பாத்தீங்கன்னா, so anaxic denitrification நடக்கும். இங்க aerobic process வந்து பாத்தீங்கன்னா will be high, because we are providing air vent here. Okay, so air vent pump கொடுக்கறனால air வந்து பாத்தீங்கன்னா pass through ஆகும். So vertical direction. But in case of horizontal, we won't provide any air vent pipe. So there it will be in either anaxic condition or anaerobic condition. But in case of vertical flow constructed wetland, we are providing air vent. So here it will be the aerobic condition. So horizontal hybrid system la hybrid system la வந்து பாத்தீங்கன்னா horizontal flow constructed wetland, vertical flow constructed wetland. So here it will be the anaxic denitrification process. Here it will be the aerobic process, aerobic nitrification, denitrification, here nitrification process. So this நம்ம ஒரு இதெல்லாம் பாத்தீங்கன்னா anaxic system and MBBR system, same operation system, same operation procedure only. Okay, then design criteria. So for free surface water, horizontal subsurface flow and vertical subsurface flow. So detention time here, if you see 5 to 14 days, but in case of horizontal 2 to 7, but here it's not applicable because water is going to the vertical direction. BOD loading rate 8 we can go here inga pathina 8 gram per meter square per area, because we are providing high area. In this case we here horizontal subsurface flow 7.5 and vertical subsurface flow 4 to 6. So water or substrate depth will be, water depth வந்து பாத்தீங்கன்னா we can go up to 0.1 to 0.5. that means டாப் ஆஃப் த லேயர் வந்து வாட்டர் எவ்வளவு ஹைட்டுக்கு வந்து நிக்கணும், ஸ்டாக்னட் ஆகி நிக்கிற மாதிரி. ஸோ இதுல வந்து பாத்தீங்கன்னா 0.1 to 0.5. here we can go to 0.1 to 1 meter. so here not applicable because water is passing through the vertical direction. hydraulic loading rate இதுல வந்து பாத்தீங்கன்னா here it will be 7 to 60 mm per day. that means water flow here 2 to 30 mm per day, here 40 to 80 mm per day. So that means water எவ்வளவு flow ஆகுது hydraulic loading rate. Then area requirement, here you can see hectare per meter cube per day. Here we record very less area, but here also we need very less area. Then major problem for this constructed wetland is the mosquito. Since இங்க வந்து பாத்தீங்கன்னா water freely flowing, so வந்து பாத்தீங்கன்னா we need to provide mosquito control arrangement. But in case of horizontal and vertical direction, so water is flowing beneath the under the filtration system, so there won't be the growth of any mosquito system. But in case of free water surface, water is flowing top of the filtration system, so here we have to provide the proper mosquito control. So that's why in most of the conditions, so this free water surface flow constructed wetland is not suggested, and it is not operated for the any sewage treatment system. Mostly it will be used for the horizontal or vertical surface system. So வந்து பாத்தீங்கன்னா the application is very simple. So wherever we are receiving very less quantity of sewage flow, so but it cannot handle the very high quantity. So like if on the padina for any hostel, so if you see in IIT, most of the hostels will have their own constructed wetland treatment system. That means hostel irundhu vara gray water means other than toilet flushing, so bathing and washing water on the padina, it will be treated by the constructed wetland. So it is a combination of in IIT if you see, it's a combination of both horizontal as well as the vertical constructed wetland. So it's a hybrid system. So that treated water again it will be used for the toilet flushing. So individual apartment wise or individual building wise, you can provide the constructed wetland. That is the one key advantage of this constructed wetland system. So once the hybrid the treated water means you can reuse the treated water for toilet flushing. So it will reduce the freshwater consumption. Then harvest frequency, sometimes this can be used for the if you see in Madurai pathina place is called Avaniyapuram. So there where they have the 125 MLD sewage treatment plant. So 125 MLD sewage treatment plant is there. So after the sewage treatment system, this water will be used for the agricultural purposes. So வந்து பாத்தீங்கன்னா it will be for the கவுக்குலாம் வந்து போடுற அந்த கீரை, அந்த ஸ்பினாச் இருக்கும், அது பேரு வந்து பாத்தீங்கன்னா ஓகே. ஸோ அந்த ஸ்பினாச் வந்து பாத்தீங்கன்னா கவு அண்டு கோட்டு அந்த மாதிரி போடுற அனிமல்ஸ்க்கு போடுற plants on the padina, they are growing with the use of this treated sewage water. So that treated sewage water they will be harvesting and it will be used for food as a food for cow and other animals. So we can use that kind of a system also. So practically we are everywhere we are using this constructed wetland system. So if you go to any ministry website, to regenerate contaminated river, அதாவது வந்து பாத்தீங்கன்னா ஏதாவது ஒரு ரிவர் கண்டாமினேட் ஆயிடுச்சுன்னா அதை வந்து ரீஜெனரேட் பண்றதுக்கு there we can, so in a river we cannot use directly biological system, any biological any aerobic system or anaerobic system, but Ministry of Environment and Forest suggested to use this constructed wetland system within the river boundary. So river போதுனா அந்த ரிவரோடைய one part of placeல வந்து wherever sewage is entering. So if you see அடையார் ரிவர்ல வந்து பாத்தீங்கன்னா அடையார்ல வந்து பாத்தீங்கன்னா நிறைய பாயிண்ட்ல வந்து sewage is entering. So அந்த enter ஆகிற பாயிண்ட்ஸ்ல வந்து we can provide this constructed wetland treatment system and it will reduce the impact on the river system. So it won't pollute the any river. So if you see in Maharashtra, you can go on search in website. Maharashtra, they have implemented this constructed wetland to remediate the one of the contaminated river which is flowing into the city, Bombay. In Mumbai, they have implemented this constructed wetland. So IIT professor Shyam Aslokar, அவர் தான் வந்து பாத்தீங்கன்னா he designed the constructed wetland system. He is one of the expert in constructed wetland. So he designed the constructed wetland which can be directly used in a river system for the minimizing the pollution. So this is then strong point, site location, simple operation and maintenance. So we don't provide any electrical or mechanical equipment, electromechanical equipment. So it is simply working on the natural treatment. So வந்து பாத்தீங்கன்னா there is no only thing is இங்க influent மட்டும் தான் கொடுக்குறோம். Effluent also will be coming as gravity itself. So there won't be any electromechanical and can be integrated and into landscaping. So attractively landscaping. So we can provide this as a landscaping activity in any commercial industrial business. The major thing is mosquitoes. So mainly on in free water surface system, and also startup problem, space requirement. So because it needs larger space when the flow is high, and variable performance possible because it won't give the constant result, but here we will be providing, and this is still largely empirical. So we need to provide larger design empirical system. So this is the one how we can calculate the area of constructed wetland. So like suppose so this is a one thumb rule formula. So we know that area of the constructed wetland can be calculated with the inflow system. Inflow, that means quantity, and concentration, and the outflow quantity and outflow. So the mostly inflow and outflow will be very same. We will be considering as the average inflow. So average inflow, then influent BOD concentration, and outflow BOD concentration, and BOD rate constant. So 0.1 per day. 0.1 per day is the rate constant. So நீங்க வந்து calculations you will be using. So the general formula is area of the constructed wetland. It's a thumb rule only. It's not a correct value. It's a thumb rule. Will be the land C0 minus land CT divided by KBOD. So like ஒரு எக்ஸாம்பிள் நான் கொடுத்துருக்கேன். So 50 KL means 50 meter cube per day of sewage is generating. So அதோட inlet BOD வந்து பாத்தீங்கன்னா 30, then outlet BOD வந்து inlet BOD 20 milligram per liter, outlet BOD is 30 milligram per liter, then KBOD is the 0.1 per day. So what will be the you can calculate the thing. I have not done the calculation. You just calculate and check it. Later we can discuss this results. So this is the one laboratory application. So this is used in a laboratory purpose. So if you see it's a developed constructed wetland. So இதுல என்ன வந்து பாத்தீங்கன்னா it has a 4 different constructed wetland வந்து பாத்தீங்கன்னா they have considered, and it is filled with the P gravels. The D50 is of 10 mm, range is 4 to 25 mm, and medium gravel 4 to 40 mm diameter, and cobbles, it's a pebble, and here we are using biochar. So இதுதான் வந்து I was telling. So we can use biochar in the constructed wetland system. So it will improve the treatment process, filtration, and biological degradation. So that is the one modification we can provide for a biochar. Biochar on the pathina we can provide. So P gravel, medium and gravel, then pebbles, and biochar. So if you see the arrangements, so top bottom layer is the medium gravel and P gravel, and ஒரே ஒரு இதுல வந்து பாத்தீங்கன்னா we are providing pebbles. So 4 different wetland is taken for the study. So wetland A, wetland B, and wetland C. So it's a name of the, so length is 1 meter, so it is constant. Width of the wetland is 0.33 meter, it is constant. Depth is 0.3 meter, so it's a very less depth. So we can go up to 1 meter or 0.8. So 0.8 meter up to 0.8 meter we can go. So here we are providing 1 meter. The total volume is this. Porosity of the system is you can see that first 2 reactors having a very less porosity, and other 2 reactors having more porosity. The flow rate is very same, and volume is same. Hydraulic retention time, it's 3. So to achieve this hydraulic retention time, we have to consider this flow, volume, and length with the depth. So we already calculation போட்டிருப்பீங்க. Then in this wetland C and wetland D la vandu pathina we are providing biochar. Then other things la very common. So inga vandu other 2 wetlands are really very common, but only wetland C and having we are providing 33.1 kg of wetland biochar, and wetland D la vandu pathina 16.5 kg of wetland. Then another difference is vegetation type. So here in wetland A we are not providing any vegetation. Then wetland B, C, D we are providing kanna species. So vandu pathina it's a common, you might have seen this trees wherever sewage is flowing na, this trees will be automatically growing. So on the trees. So this trees having the high ability to uptake the organic contaminant present in the soil or water. So if you see this trees only, this cannabis is trees only mostly used for the constructed wetland. So because it's a pollutant removing trees. So these are the 4 different specification. So if you see that one is wetland A, wetland B, wetland C. So difference are there. So one is one is mainly on the porosity. Porosity there is a different. Then second one is biochar, there is a different, and third one is vegetation, there is a different. So okay, so porosity is 655 to 659. இதுல வந்து பாத்தீங்கன்னா இது because we are providing biochar, that's why the porosity is little bit increased. If you see the result means total nitrogen, nitrate, ammonia, phosphate, ammonical nitrogen, phosphate, total phosphorus, COD, total suspended solids. So if you see that wetland A, wetland B, wetland C, wetland D. So வந்து பாத்தீங்கன்னா total nitrogen wetland C ல வந்து பாத்தீங்கன்னா very high. So wetland C ல நைட்ரேட் வந்து பாத்தீங்கன்னா வெட்லாண்ட் சில தான் ஹைட்டா இருக்கு. அம்மோனிக்கல் நைட்ரேட் வெட்லாண்ட் 4ல வந்து வெட்லாண்ட் டில வந்து பாத்தீங்கன்னா ஹையா இருக்கு. தென் பாஸ்பேட் ரிமூவல் பர்சன்டேஜ் வந்து பாத்தீங்கன்னா வெட்லாண்ட் சில ஹை, இட்ஸ் வெரி ஹை. தென் டோட்டல் பாஸ்பரஸ் ஆல்சோ இட்ஸ் வெரி ஹை. COD removal also, if you see that highest is wetland C. So turbidity and suspended solids, if you see that all the wetlands having the ability to remove turbidities because we are providing all the filtration system. So this filter unit will be take care of the turbidity removal. So வந்து பாத்தீங்கன்னா turbidity is completely and turbidity and suspended solids have been completed removed in the all the 3 systems. But when you comparing to the other when you see that other parameters, so mostly wetland C and D are the higher efficiency. In that wetland C is a little bit higher. Why? Because here we are providing a biochar system. So this biochar having the high porosity and it acts as the filtration and it supports the biologic bacteria growth. Attached growth process la vandu pathina the major reason for removal of all the pollutant is in this system vandu pathina biological treatment. So here it is promoting biological growth, so mainly on the filtration and it promoting the biological growth also. So because of that here more pollutant removal is coming. So this is the one example. You can try this biology, you can take this kind of a treatment system for your project and you can implement in your உங்களுடைய காலேஜ்ல வந்து பாத்தீங்கன்னா ஹாஸ்டல்ஸ்ல இருந்துச்சுன்னா you can use this treatment process and you can trial it how it is efficient. It is very simple process, there is not much mechanical equipment. So only thing is you have to provide the flow. So here the inflow so only here the outflow, bottom is outflow. So only thing is you have to provide this inflow and outflow equipment. So so mostly these systems are using for the individual households. So commercially we are using it has been used in for the president's house. President's house la vandu pathina it is used as a tertiary treatment, but for gray water treatment ku vandu pathina this is the one of the best treatment system and the treated water can be again used for the either for gardening purpose or it can be used for the toilet purposes. Okay, so this is the constructed wetland. So what is the answer of what is the answer area required for this flow of BOD and COD? Is anyone calculated? See, please calculate the area requirement. So this is a simple one. I have not done the calculation, so please calculate the area for this much flow. 50 KL is a 50 meter cube per day. The flow is 50 meter cube. Inlet BOD is 200 milligram per liter. Outlet BOD is 30 milligram per liter. But outlet la vandu pathina right now we are going for, if it is a Chennai city means outlet BOD will be very less. So calculate both the things. So same system, but influent வந்து பாத்தீங்கன்னா influent is concentration is very common, but outlet BOD only changing. What is the answer? How much it is coming for the first one? Sir, கேக்குதா? Okay, this is for first one or second one? So 948, okay, from one. Okay, second one. Okay. So 948 unit is meter square. So first one பாத்தீங்கன்னா 948 meter square area it's required. Then second one is 1497 meter square area is required. So இதனால தான் வந்து பாத்தீங்கன்னா we won't provide for constructed wetland for the raw sewage treatment system. So that's why we are providing some pre-treatment, either as a septic tank, either septic tank or any other biological treatment system. So it will reduce the area required for the constructed wetland design. So in case of same வந்து பாத்தீங்கன்னா if you just put 30 here 30 milligram per liter போட்டா here 30, just to understand the concept. You can unmute and you can talk. Suppose வந்து பாத்தீங்கன்னா already we have provided some biological treatment system. So the treated sewage has a inlet BOD of 30 milligram per liter, then outlet BOD is 10 milligram per liter. So then how for this quantity, how much area is required? Just for the understanding. Same formula, instead of 200, we need to provide 30. Uh, 545 meters square. So even though it is very high, 549 meter square area is also, it is very high. Okay, but anyhow, if we want to provide constructed wetland, means it always take big larger area. So that's why constructed wetland is used for the small treatment capacity rather than for the big treatment capacity, or it will be used as a tertiary treatment. So major example for this constructed wetland is our president house. So you can try this kind of a laboratory experiment. So this is the very simple operation, simple design. There is not much design complication, and you can use different filtration media. So different various depth, various varying depth of each filter media, varying the weight of each filtration media, and using biochar. And this biochar you can manufacture from different any organic waste. So வந்து பாத்தீங்கன்னா it can be generated any organic waste. So either வந்து பாத்தீங்கன்னா right now it's a summer season, so there will be a lot of tender coconut shells will be there. Okay, so a lot of tender coconut shells will be sometimes disposed as a solid waste, but we can think that that tender coconut things can be it can be it's a simple process. Biochar is not generating developing a biochar is not a big process. It's a simple process. You can develop your own biochar and you can apply to any treatment system. It's a big project. It's a value added to the environment system, and this treatment system can be applicable to your to small apartment or hostel hostel systems பண்ணலாம், or ரெயின் வாட்டர் சிஸ்டத்துக்கு நம்ம யூஸ் பண்ணிக்கலாம். ரெயின் வாட்டர் harvesting சிஸ்டத்துக்கு we can use this one. So simple treatment techniques, but it can be applicable to the all the system. Okay, so that's all. So next class I will be discussing in other topics of the syllabus, and the last class will be discussing on the opportunities and technical aspects of civil engineering thing. So if you have any doubts, you can ask. Any questions? You can still you are in a third year, so நீங்க வந்து பாத்தீங்கன்னா next final year போறப்போ வந்து பாத்தீங்கன்னா you can do this constructed wetland project. So it's a very simple operation. There is not much maintenance also, so you can simply you operation it's a value added project. So or you can plan for the grey water systems. Grey water, so ஹாஸ்டல்ல இருந்து வர கிரே வாட்டர் சிஸ்டத்தை வந்து பண்ணலாம், ஆர் உங்களுடைய கேன்டீன்ல இருந்து வர வாட்டருக்கு நீங்க வந்து யூ கேன் டிசைட் திஸ் ட்ரீட்மெண்ட் சிஸ்டம். ஸோ யூ கேன் டிசைன் திஸ் ட்ரீட்மெண்ட் சிஸ்டம் ஃபார் எனி ஸ்மால் சோர்ஸ் small source small sources. Any doubt on this? So today we have discussed UASB reactor. It's a simple anaerobic reactor and constructed wetland. Any questions, sir? It's so silent, sir. Yes.
I think no questions from students.
But it is clear or not, sir? I just want to
Yes,
understand
sir.
because
Yes, sir.
online
It's clear. Yes, sir. It's clear.
not able to see anyone. It's a little bit
Yeah, yeah,
difficult.
yeah. Yeah, it's clear.
uh, yes, sir. Yes, sir. I will share the presentation to you, sir. So you just share
Okay,
it.
okay, sir. No problem.
Uh, shall I leave, sir, or any?
Okay, sir. Okay, sir. So we can wind up. Now the time
Okay.
is 2:13. Okay, no issues.
Oh, okay. Okay. Thank you, students. Will sir, if possible, tomorrow also I can take tomorrow
Yes, sir.
morning.
Third
If
and fourth, sir. Tomorrow.
tomorrow morning. Okay.
Yes. We can
Okay.
have class.
Okay. Okay, sir. Tomorrow.
Okay.
Thank.
Okay.
Thank you, sir.
Thank you.
Thank you.